5.2 inverse functions. Number 1, inverses. So example, if we have a relation, let's call it H, with the following description. -8 goes to 5, 4 goes to -2, -7 goes to 1, 3.8 goes to 6.2. So that is a relation called H. The inverse of H will be a relation when we switch the x and the y. So 5, -8, -2, 4, 1, -7, 6.2, 3.8. So x is interchange with y to find the inverse. Now that is for relations, inverse relations. Now we're going to talk about inverses and one-to-one functions. So if the function has an inverse, and if that inverse is also a function, we call that function one-to-one. So definition, a function f is one-to-one if its inverse is also a function. So we start with a function, example, g of x equals x squared. Show that g is not one-to-one. In other words, the inverse is not a function. So here is a function y equals x squared. If we switch x and y, so switch x and y, and we have x equals y squared, or y equals square root of x, and y equals negative square root of x. So we have two equations for y, so this is not a function. So if the inverse is not a function, so the original function g is not one-to-one. And we can see that from the graph. So here's g. The inverse relation will be this, and that is not a function. So this is x equals y squared, not a function. So the original function g is not one-to-one. So we have a test that tells us whether a graph is a graph of a one-to-one function or not. We call it horizontal line test. And it works like this. If the graph intersects the graph, if the line, horizontal line, intersects the graph in more than one point, then it is not one-to-one. So example, is the graph of a one-to-one function. So we're going to show several graphs. First we have linear, then we have, I already saw the parabola, that it's not. So let's do this. Let's do cubic. And what else? Let's do polynomial. Okay. So we perform the horizontal line test. Horizontal line, 1 point. Yes, this is a function. Horizontal line, 1 point. This is a function, not a function. So number 3. What was number 2? Number 3, finding formulas for inverses. So here's the procedure. Number one, replace f of x with y. Number two, switch x and y. Number three, solve for y. And number four, replace y with f negative 1x, because this y that we got here, it's not the same as the first y. So it's the y for the inverse. So example, determine whether f of x equals 2x minus 3 is 1 to 1. Determine if f of x equals 2x minus 3 is 1 to 1. If yes, find the formula for the inverse. So it has to be a one-to-one function first before we follow the procedure for finding the equation for the inverse. So first step was replace f of x with y. I will need to answer the question if it's one-to-one, but this is a line with a slope 2 and y-intercept 3, so you can mentally see it passes the horizontal line test, so it is one-to-one. So y is 2x minus 3, switch x and y, and solve for y. Divide by 2. So y equals x plus 3 over 2, and it says the last step replace y with f negative 1x. So this is the equation for the inverse. So if we graph these two, we'll see that the graphs, note, the graphs of f and the inverse are symmetrical with respect to the line y equals x. So let's have another example and then we'll see the symmetry here. Example, g of x equals x to the third plus 2. If it's one-to-one, find if it is one-to-one. If yes, find the inverse. So we can sketch it. We know the transformation of the cubic function. So this is 2 points up. Let's see, 1, 2. So we have this graph transform 2 units up from the parent function x to the third. And so this is our original function. It is one-to-one because it passes the horizontal line test. So now let's do the steps when we replace, well, first replace g of x or f of x with y. Then we switch x and y and solve for y. So y is equal to cube root of x minus 2. Replace y with the inverse. Well, it's going to be g negative 1 of x. So it's cube root. And so if we graph this, it's 2 units to the right. And so it looks like this. So this is our inverse. And as you can see, these two graphs are symmetrical with respect to the line y equals x. So this is the line y equals x. We have the symmetry. And number 4, inverse functions and compositions. So if I compose two functions, but not any two functions, f and its inverse, by definition, that's f negative 1 of f of x. And that is equal to x. We call this cancellation equation. And so this is true for every x in the domain of f. And then if I compose these two in different order, that is f of f negative 1x, that's equal to x as well, for every x in the domain of f negative 1. Number 5, restricting the domain. So if we have a function that's not one-to-one, for example, y equals x squared, we can restrict the domain, so it is. So if we take this function and restrict the domain to be from 0 to infinity, then it is one-to-one. And it has an inverse. So here is a restricted domain for a function. So switch x and y, solve for y. And here's our inverse, square root of x. This concludes the video for 5.2.